In this presentation, we will be discussing the concept of projectile motion and the various factors that influence the path of a projectile. A projectile is described as any object thrust into space by some force exerted on it, while projectile motion refers to the uniform path the projectile takes from its starting position to where it lands on the ground.
The typical pattern of a projectile in motion follows a parabolic curve. That is, an object starts from a certain position with an initial velocity, travels through the air reaching a peak height, and drops to the ground some distance away due to the downward force of gravity. The initial velocity and takeoff angle of a projectile prior to release determine the path of the projectile in motion. In this presentation, we will look at how different takeoff angles affect horizontal displacement of a football during kickoff, assuming initial velocities are constant.
In an ideal experimental situation and excluding air resistance, the optimal takeoff angle of a projectile for maximum horizontal displacement is 45 degrees. Is this the case?
Due to the effect of air resistance and drag force, an ideal angle of 45 degrees is not realistic. In this instance, we found that an angle of 31.9 degrees is the optimal angle for the longest horizontal displacement. But how far does the ball actually go? The initial position was on the 25-yard line, and with a takeoff angle of 31.9 degrees, the final position of the ball was on the 13-yard line, resulting in a kick of 62 yards.
Next, the kicker performs a squib kick, in which he strikes the top of the ball, sending it a short distance downfield. By kicking the top of the ball, the takeoff angle is less than 45 degrees. Ideally, the effect of this decreased takeoff angle would result in a horizontal displacement less than that of the kick at 45 degrees.
As you can see, the takeoff angle is 15.8 degrees, far less than the optimal angle. What does this do to the distance that the ball traveled? The ball travels in the air 16 yards to the 41-yard line. This is consistent with a smaller takeoff angle yielding a shorter horizontal displacement.
Next, the kicker performs a pooch kick, in which he seeks to pop the ball high in the air by kicking the bottom of the ball to maximize potential takeoff angle. In an ideal situation, a takeoff angle of greater than 45 degrees will result in a horizontal displacement less than that of a kick with a takeoff angle of 45 degrees.
As you can see, the kicker kicks the ball at an angle of 46.5 degrees. What does this new takeoff angle do to the horizontal displacement? This takeoff angle sends the ball downfield 27 yards to the 48-yard line. Again, this takeoff angle yields a horizontal distance less than that of a kick performed at a takeoff angle of 45 degrees.
We know that in an ideal situation, a takeoff angle of 45 degrees will result in maximal horizontal displacement. Due to air resistance and drag force, our experiments showed an optimal takeoff angle of 31.9 degrees and resulted in a horizontal displacement of 62 yards. From this, we learned that air resistance and drag force greatly affect the path of a projectile.
In case you missed it the first time, here's the optimal takeoff angle kick again.